Hello and good day, everyone. My name is Mujtaba, and today, with my friend Aryanul, we'll be doing a presentation on the EV range prediction model that we have made. Okay? So, these are the stuffs that we'll be covering today. We'll start off with the architecture description, where we will explain what Amazon services we have used and how they are interconnected to each other. Next, we'll look at the machine learning model that we have chosen and why we have chosen it. Then we'll deep dive into the IoT Trend Maker itself. Then we'll look at the dashboard that we have created using Amazon Grafana. Then we'll showcase our extra stuff that we have done to improve this project even further. Then we'll also share our future enhancement plans to take this project to next level. Then we'll conclude our presentation by doing a real-time demonstration. ठीक है?
Let's walk through the architecture of our solution. We start by sending raw data in the form of a CSV file to AWS IoT Core. From there, the published data is stored in a DynamoDB table. This serves as a foundation for our machine learning process. Using the stored data, we perform prediction and model training in Amazon SageMaker. Once trained, the model is stored securely in Amazon S3. Next, we calculate the predicted range and store this result back into the DynamoDB table. This stored data is then sent to IoT Sitewise, where it is published to AWS IoT TwinMaker. Utilizing TwinMaker, we designed a comprehensive dashboard in Grafana for real-time visualization. Finally, we implemented an AWS Lambda function. This function is triggered by DynamoDB to send notifications such as low battery alerts, ensuring proactive monitoring.
Now we'll look into the machine learning model that we have chosen to do the prediction. So the machine learning model that we have used is random forest. Why we have chosen is because it is a supervised learning model. It reduces overfitting. It helps identify which variables have the most influence in the range prediction. And you could see that in the graph in the bottom right of the screen as well. And at last, it is robust to outliers and missing data. And if you see on the bottom left screen, we have also developed a program which asks for user prompts. So let's say if I enter Audi, it would give me the prediction range for all the Audi models. And if you see the model evaluation metrics on the top right, you'd see the results that we have gotten from this model. And just below that, we have also developed another program where if you enter a car model code that we have predetermined it would it would show the predicted range for that particular car. Okay. What are we predicting using this model? So the thing that we are predicting using this model is the range at which the electric vehicle can go in a full charge in different environmental conditions, desert, highway, and terrains. So if you look at the pictures here, you could see different cars in different environmental conditions showing different range predictions. What this says is our model is robust to any environmental conditions that the EV car is in, and what inputs are we using to predict these values. So the variables that we are using to predict these outputs are price, top speed, acceleration, battery efficiency, and fast charge. ठीक है ना? So this is the scene that we have made using the IoT Twin Maker. We have imported all the 3D models from the internet. And if you could see over here, you could see different cars in different environmental conditions. You cannot see the prediction range of the cars, but we'll show you that in the Amazon Grafana when we do a real-time demonstration.
Now let's look at the dashboard we created to visualize the data. Using AWS IoT TwinMaker Grafana, we built a detailed scene that represents the EV and its key components in a dynamic 3D environment. In Grafana, we integrated this with two key visualizations, a time series graph that tracks the predicted range over time, helping us monitor trends and performance, a Gauss chart that displays the current battery level, offering a clear, real-time snapshot of the EV's battery. This combination of visual elements allows for intuitive monitoring, providing both high-level insights and detailed data points in one cohesive view. ठीक है?
Now, for the extra stuff that we have done to improve this project even further. So, we have made a EV car range predictor application which asks for user inputs and gives the predicted range of the car in highway, in mountain, and in desert. It also displays the results in both bar and line graphs. It also has a button to export the entered values into a CSV file, either by creating a new one or adding a new entry to an existing one. So this is our future enhancement plans that we have thought about to take this project to next level. First, we'll integrate the EV car range predictor application with AWS services so that it could smoothly take new entries. We also plan to add additional environmental conditions to improve the accuracy of the range predictions under various circumstances, such as snow. Next, we also plan to utilize a weather API to fetch real time weather information and factor it into the range prediction model for enhanced reliability. And at last, we plan to send a notification to phone when the battery of the car is low using AWS Lambda and Amazon Simple Notification Service. Take care.
This is the CSV file which we are using to do the prediction. So let's move on to our IoT core, where we are publishing our data. As we can see, we are the data is published on real time by the name of battery, car name, link, and all the attributes. And then we are using a Python code to store this data to a DynamoDB table, which we can see over here. The all 300 plus data is stored to a DynamoDB table by all the cars, and then we are using this stored data to do a prediction in using SageMaker. So as we can see here, we get model evaluation metrics, which shows our mean absolute error, our root mean square error, and R square score. And then we wrote a code in which the model asks the car model code as we uh, for example, if we enter 3, so it gives predicted range for all the BMW cars as BMW is assigned 3 for the car model code. Then the other code, it asks for the brand name. Suppose if we enter BMW, so it shows all the predicted range for all the BMW cars which is stored in our CSV file. So now we are saving this predicted model to our S3, and then we are send and saving and we save this predicted model to DynamoDB table again. As we can see, it has the predicted range also, and then we are using this saved data from the DynamoDB table to send it to IoT site-wise. As we can see here in our IoT site-wise assets named EVCar1, these are the assets we have created: acceleration, battery, and one more thing, we have wrote a Python code to and we have written a Python code which calculates the mountain range and the desert range also. Here you can see, and we save this predicted range at mountains and desert to a CSV file, and then we are So moving on to the IoT site wise, so this is the assets we created, and now we'll run our Python code to publish the data to IoT site wise. As we see, we run our Python code to publish the data, and it's sending the data to our IoT site wise, and we can see over here these are the latest value which is shown, and I have set a threshold time of 14 seconds to send data at each 14 seconds. So as we can see that these are the latest value which are getting published at after each 14 seconds. And then we created a scene IoT in IoT Twin Maker, as we can see over here, and we have created multiple annotation by the name of desert range, mountains range, predicted range. Moving on to the our Amazon Grafana. So this is our Grafana dashboard in which there is a battery gauge which shows the battery percentage in kilowatt hour, and it keeps changing in real time, and there is a time series graph which shows the predicted range of the desert range, mountain range, and the normal predicted range on real time. As we can see over here, it is giving a it is showing a time and the mountain range based depending on that time. And this is our dashboard. If we zoom in, so as we can see, we there is a normal predicted range with a display of battery, top speed, and then efficiency and acceleration. If we move to the other side of our model, we can see the mountain range, which is also being shown on our Grafana dashboard 3D model, and there is a desert range also, which is being shown in our 3D model. So these data are the data published from the CSV file to the IoT site wise, which we have done earlier, the prediction, and we have calculated the desert range and mountain range through a Python program, which me and Mustafa done. So, moving on to our lambda function, we created a lambda function which is being connected to our which is being triggered by the DynamoDB, and as we can see here, there is a lambda function. If we test this function, so it shows succeed, and we can see over here we get a notification of low battery alert, that warning Tesla Model X has a low battery of 15%. So it shows, it gives alert whenever the battery is low of the EV car. But the thing is, uh, in our CSV file there is no car model which has a low battery actually between we actually have set a threshold of 15%. So there's no battery car model which have battery lower than 20%. So I'm doing this manually for now, and then
Now we'll look into the EV predictor application. Take some time. Okay, so this is our application that we made. Here you can enter the required values and it would give the predicted results of the EV car range. So let's load an example value here. So what this function does is it loads a preset values so that we can easily test this application. Now we click on the predicted range button. Here you can see the predicted range, mountains range, and the desert range. When I click OK here, it shows me a line plot plotting the values of the EV range in different conditions. Now when I close this, it shows the results in a bar graph. So as you can see over here, the predicted range has about 600 kilometers, where the predicted range in mountain is about 420 kilometers, and in desert it is about 500 kilometers. Now when I close this, you can also export the results in a CSV file using this button. As you can see, the results have been exported to this CSV file. Because I have not created any previous CSV file in this desktop, it creates one for me over here, if you can see. We also plan to add some features such as more stats, different line plots, and different graphs and settings, but settings function in the future. Thank you.